in this video, we are going to apply the rate of change to word problems. So we just brief review what we have done for the rate of change. Average rate of change also is a slope of secant. It's a difference quotient. Quotient means division. So delta y, difference of y divided by delta x, difference of x. In function notation is f at b minus f at a divided by b minus a. So the 2 points, one is a input, output is f at a. And another point is b. Input is b, the output is f at b for the function f at x. So y difference divided by x difference, we call it average rate of change. And instantaneous rate of change is a limiting value as h approaches 0. So we have 2 points. One is a, f at a. Another point is a plus h. Then the output is f at a plus h. So the difference of y, f at a plus h minus f at a, all over the difference of x, h. As long as we could find the limiting value of this limit, then we are able to find the instantaneous rate of change. Let's see one example to find the average rate of change and the instantaneous rate of change. So a rock falls from a high cliff. The position of the rock is given by y equals 16 minus 5t squared. It asks you to find what's the average speed. So this is a position. So the average speed is changing of the position divided by the changing of the time. So it's looking for the rate of change. Average rate of change is just the slope of a secant. So first 2 seconds is from 0 to 2 seconds. So we have a point 0, comma, then we sub 0 here to find the y value, then do the same thing. We sub in t equals 2 to find the y value, then we have the 2 points. First point x1, y1, second point x2, y2, then we use a rise over run, y2 minus y1 over x2 minus x1, then we could find the slope. So this is a rough work. This is what we are going to look for. So whenever you have a question ask you to find average speed rate of change, you need to ask yourself, is slope of secant or slope of tangent? If slope of secant is just normal slope of 2 points, you just need to find the 2 points. So for example 1a, we know that is average speed is average rate of change. So we just need to find the 2 points. So we are going to use y2 minus y1 over x2 minus x1. And what we have to do is we need to find when x equals 0, what's y equals, that is our x1, y1. So we call this is like the table of values. X value given, find the y, we sub x value here. So here we use a t, so we are going to use a t value. So t equals 0, this is our x1. Then y equals 16 minus 5. We plug in the t equals 0 to the original equation, then we have 0 squared, but minus, do the exponent first, only the base squared. Base is 0, 0 squared. So it's 0, then 5 times 0 give you 0. We have 16 minus 0 is 16. So this is our first point, 0, comma 16. Then the second point is t equals 2. Then y equals 16 minus 5 times 2 squared. Do the exponent first, that is 4. So 16 minus 5 times 4. then do the calculation. This multiplication first, minus 20, it will give you negative 4. So this is our second point. Then the slope is just y2 minus y1 over x2 minus x1. Here is t2 minus t1. So we just use this is a second point, or you can use this one as second point, this is as first point. It doesn't matter, okay? If we use this one as second point, so negative 4 and 2 at the first term, and minus y1 is 16, x1 is 0, so we have negative 20 over 2, then equals negative 10 meter squared. So although it didn't say it, so by default it is y in meters, okay? Then the t is in seconds. So this is for average speed, rate of change. And question 2b, what's the instantaneous speed at 2 seconds? So if it asks you to find the speed at 1 time, that is instantaneous, that is slope of tangent. So for slope of tangent, we have the definition from the limiting value when h approaches 0, and so this one, it should be function at a plus h minus f at a all over h. So this is in function notation form, it's not in the xy notation form, but we could use the same idea. We are going to do it is when t equals a plus h, then what's the y value? That is f at a plus h. So we sub in a plus h to the given function. We have file bracket a plus h bracket squared. Then we could do the expanding, so 16 minus 5, this is perfect square. It will be a plus h times a plus h. We could use a times a, first term time in the first bracket times each term in the second bracket. We are going to have a squared plus ah. Then second term in the first bracket times each term in the second bracket. So h times a is same as a times h. H times h give us h squared. Then we collect the like terms. We are going to have a squared plus same variable, same degree, ah, variable same, degree, no degree means 1. So a1, a1, h1, h1, so you have both variable and the degree same, they are like terms. If you have like terms, adding, subtracting, you just add the number at front. No numbers at front of ah, by default is 1. So multiplication, no numbers is 1. 1 plus 1 is 2, so we have a squared plus 2ah plus h squared. Then we are going to do the multiplication first. So negative 5 times each term in the bracket. We are going to have 16 minus 5a squared, negative 5 times 2, negative 10 ah, negative 5 times 1, negative 5, then h squared. We don't have any like terms here, so this is simplified. Then we are going to do the f at a. So when t equals a, f at a is just subbing the a value to the x. So a replace x, we have a squared. Then it's just 16 minus 5a squared. Now we are going to sub in both to the limiting value equation. We are going to have limiting value when h approaches 0. So divide by h, then a plus h, f at a plus h is 16 minus 5a squared minus 10ah minus 5h squared. Then minus, when x equals a, the output, minus bracket, remember, put in bracket. Because it's minus at front of the bracket, you expand the bracket, you need to change both sign inside the bracket. So we are going to have limiting value when h approaches 0, then 16 minus 5a squared minus 10ah minus 5h squared, then minus 16 negative 5 plus 5a squared. So the sign inside the bracket both change to the opposite. Then we are going to collect the like terms. 16, there's no variables, they are like terms. 16 minus 16 is 0, then negative 5a squared, positive 5a squared, a variable same, degree a squared same, they are like terms. Negative 5a squared plus 5a squared is 0. Now we are going to have limiting value when h approaches 0. We have negative 10a times h minus 5h squared. Now we are going to divide it two terms by h. Then we are going to have limiting value when h approaches 0. Negative 10ah divided by h cancel out, negative 10a. Negative 5h squared, h squared divided by h, we have negative 5h. 2 minus 1 degree. When you do the same base power division, degree subtract. 2 minus 1, you have 1h there. Now we don't have the denominator h there. We could sub the h value into this expression. So we have negative 10a minus 5 times 0. Then we are going to have equals negative 10 times a. Minus 0 is negative 10 times a. So this is a slope of tangent at x equals a. And for this question, it asks you at 2 seconds. So it means our a value is 2. So we continue here. Now t equals 2, so a equals 2. Then the slope, instantaneous speed is negative 10 times 2, give you negative 20. So this distance is meter, time is seconds. So this is instantaneous speed. Then this question is done. So from this question, you will see we have found the average rate of change by using the slope of secant formula. Then we find the instantaneous speed, that is the instantaneous rate of change using the limiting value. Then we sub in the a plus h to the given function. Then sub in a to the given function, then we do the subtraction and do the simplifying. Our goal is get rid of the h at the denominator. Once we don't have the h at denominator, then we could sub in the h equals 0 to find the instantaneous rate of change. And we are going to sub in the x value in this one is t value as a value, then we find the instantaneous speed, the rate of change. Now we are going to practice one more example, and if you like, you can pause the video and try this question by yourself, then play the video, check your final answer. So this one is given in the function notation. H at t equals negative 4.9 t squared plus 16t plus 1. This describes a toy rocket launched straight up, and its height h in meters and time in seconds. It asks you what's the speed of the rocket at 1 second. So whenever you are looking for the rate of change question, first question you want to ask yourself is, are you looking for the slope of secant, or are you looking for the slope of tangent? How to tell? See if you have 1 time or 2 times. So you have at 1 second, so it means at 1 point. Then you know this is a instantaneous rate of change, is slope of tangent. So now we are going to write the instantaneous rate of change formula out. So h approaches 0, f at a plus h minus f at a, then divided by the input difference, a plus h minus a give you h. So this is a limiting values for the instantaneous rate of change, and that is a speed we are looking for at 1 time. And now we are going to sub in the a plus h to the function notation. So negative 4.9 a plus h, plug in the a plus h for t, then plus 16 a plus h plus 1. Take away bracket, plug in a for t, so negative 4.9 a squared plus 16a plus 1. Then all over h. So equals limiting value when h approaches 0. So we expand this perfect squared at 4.9 bracket, first term a squared, double of these 2 terms multiplication, then plus h squared. Then expand. Why we expand all the bracket? Because we want to collect the like terms. When the variable numbers inside the bracket, we are not able to collect the like terms, so we want to get rid of the bracket. The bracket, no operation sign between, it means multiplication. So 16 times a, 16 times h, give you 16h. Then plus 1. So minus bracket, we want to get rid of it. We apply the negative sign to each term inside the bracket. It just means we switch all the sign inside the bracket to the opposite. So minus 4.9, negative becomes positive 4.9. Negative 1 times 16, negative 16, so opposite sign. Negative 1 times 1 is opposite sign with 1 is minus 1. And we just use a squared bracket divided by h to save space. Then limiting value when h approaches 0, we are going to collect the like terms. So before that, we still have 1 bracket we need to get rid of. So negative 4.9 times each term inside the bracket. So negative 4.9 a squared, negative 4.9 times 2 give you negative 9.8 ah. Then negative 4.9 times 1 minus 4.9 h squared. Plus, we could cancel some like terms here. So plus 16a minus 16a is 0, plus 1 minus 1, they are like terms, no variables, is 0. So what we are going to have is 16h left, 4.9 a squared left, then divided by h. Then we don't have any bracket inside that bracket left. We are going to collect the like terms again. So a squared, they are like terms. Minus 4.9 plus 4.9 is 0. And we don't have other like terms, so we just copy negative 9.8 AH minus 4.9 h squared plus 16h. Then divide by h. We could bring that h to the denominator. Then we are going to divide it each term by h. We are going to have limiting value h approaches 0, negative 9.8 a. h divided by h cancel out. Then the second term, minus 4.9 h squared divided by h. 2 minus 1 give you 1, so 1h left. 16h divided by h. 1 minus 1 degree cancel out is 0, so no h left, plus 16. And from here you will see you don't have the h at denominator. We could just sub in h equals 0 now. So we have negative 9.8 a minus 4.9 h equals 0 plus 16. Collect the like terms. We have negative 9.8 a. This 4.9 times 0 is 0, so plus 16. Then this is an instantaneous speed at t equals a. Now we have t equals 1, so the a value is 1. So we sub. So t equals 1. Then we sub a value equals 1 to the instantaneous rate of change. We have negative 9.8 times 1 plus 16. Then we do the calculation. We have 6.2 meter per second. This is instantaneous speed at t equals 1. Then after that, we are going to see the next question. The next question asks you, what is the speed equal to 0? When is the speed equal to 0? So we are looking for the t value. And the speed equals 0 at rest. So we have only one time. So it means it asks you when the instantaneous speed equals 0. Or in other words, is when the instantaneous rate of change, the slope equals 0. So speed is 0, then it's not moving, so it at rest. So for the second question, so I will write as B. It asks you to find when m equals 0, then t equals what? So we have the m equals negative 9.8 plus 16, so 0 equals negative 9.8 a plus 16. So this a value is when the instantaneous speed is 0. So in order to find the a value, this is a linear equation. We want to isolate a. So we want to move the numbers to one side and a to other side. We could move the 16 to other side by doing opposite operation is subtraction. So we minus 16 to both sides. 16 minus 16 is 0. The right side you have negative 9.8 a left. Then the left side is negative 16 plus 0, so it's minus 16. We don't want to see the negative 9.8 at same side with a, so we move the negative 9.8 to other side. And this time it's not adding, subtracting. No sign between negative 9.8 and a, it means multiplication. The opposite operation to multiplication is division. So we divided negative 9.8 to both sides. So a long bar divided by 9.8, it means this side divided by 9.8, this side also divided by negative 9.8. Then we are going to have 16 over 9.8. Negative divided by negative give you positive. Then negative 9.8 divided by negative 9.8 is 1, so A left. When you use your calculator, you will be able to find out when the speed will be 0. So we use calculator, we find out it's around 1.6 seconds. So therefore, we are going to write the instantaneous speed at 1 second is 6.2 meter per second. At 1.6 seconds, the toy rocket is at rest. The instantaneous speed is 0, and that is when it's easier for you to catch it. So in this lesson, what we have covered is finding the average rate of change and the instantaneous rate of change. And the question that you need to ask yourself is 2 questions. Do you have is average instant rate of change, or it is instantaneous rate of change you are looking for? Okay. How can you tell? Is you have a time interval, or it's just 1 point? Then after you decide which one you are looking for, then you could use a corresponding formula for it. Average rate of change is just a slope of 2 points, and instantaneous rate of change is limiting value, that is when h approaches 0, f at a plus h minus f at a all over h. And if the instantaneous rate of change is given, then you set up the equation and solve for the a value by using solving the linear equation. So this is what you need to know, the learning goal for today. So from the word problem, figure out which one you are looking for, average rate of change or instantaneous rate of change, and apply the formula accordingly. And if instantaneous rate of change is given, then you set up the equation and find the time, the input. So thanks for watching.